Hello, friends. Okay, so today we are doing everyone's favorite topic. It's statistics. Are you excited? I'm excited. Good. Get your TI-83s ready because we are about to have a rootin' tootin' good time. Get it? Rootin', like square rootin'. I'm so funny. Okay, so the first thing that we're going to talk about is taking the mean. So the mean is fancy for average. And I'm going to show you actually what that formula looks like because we're used to just taking the numbers, adding them, and then dividing by the number of data points that we have. But they like to show it to you real mean-like. See? What? What even is that? Basically, what this means is X with a bar over it is fancy for average. So it's just the sum of all X's, right? The sum of all the numbers that you have divided by N, which is the number of numbers that you have, right? Why do people write it like this? I don't know. You sit around all day doing math. Maybe you just want to mess with people. I'd probably do it too. I'd make it a cat. Okay, anyway, so this is what we're going to do. We're going to take that formula or just use the same one you've always used to get the mean, and we're going to calculate this mean. Now, what would be mean? There I go again. What would be mean of me, right, is if I made you take out your calculator and type in all of these numbers, add them together, and then divide, right, by 1, 2, 3, 4, 5. But I'm not going to do that because you don't have to do that. All you have to do is Control C, open up my favorite thing, an Excel spreadsheet, Control V, right? Somebody didn't do any formatting, so I'm just going to do that real quick because otherwise it's going to make me crazy. There we go. And I'm just going to name these A, B, and C. So what this is representing up here are test results for different students. So student A, student B, and student C. Okay, and what we want to get is we want to get the average for each of the students. So I'm actually going to just move this over right quick. So I can write down here my average, right? So I'm going to let Excel do the work for me, and I'm going to type in the equal sign. And I see up here in the corner, actually, the first thing that comes in is average. So I click on that, and then it's like, oh, what do you want the average of? How about this? All right, enter. There it is, a 66. We've had better days. So then I hover over this. There's the white little cross, and then there's the black one. I want the black one. I'm going to click and drag. Right, and that's going to make it so that the same equation is applied to all of these. Now, I may be looking here and saying like, oh, is that for real? Right, but this is indeed the average for that, the average for this. So what this is showing you is like, great, okay, cool, good news. I have these 3 students and they all have the same test average for better or for worse. So the problem with an average is that that's all it tells you, is it tells you like, this is the overall picture based on, you know, all of the data, and I'm giving you one number, right? So what you would think if you're looking at this is that, wow, this student has a 66 average, this student usually gets around a 66. That's not true for 2 out of 3 of these students, right? For C, for student C, yes, 66 is great. It's an accurate representation. For student B, right? Oh, not so much, right? Student B was like trucking along in the 80s, and then all of a sudden the statistics unit came along and like, just kidding. It's not that bad. It's not that bad. We have magic here. We have Excel and a TI-83. Look at this. Expecting all the statistics. Oh, man. Oh, I'm having fun this morning. Okay, so how are we going to get the whole story here? Right? There are 2 different ways that we can get more of the story on the mean, right? So we can hear like, okay, what do you mean on average, right? How many people were there in your study? How many sets of data do you have, right? So if I have only 5 tests, maybe that's not an accurate representation, right? Maybe I need to have like 20 different data points in order to really understand where this person would be at. Okay, so One way in which we look at that are these things called error bars, and they're super fun. Just switching around. Switcheroo. There we go. Right, we're back to our data set. Awesome. We see we have 66 as our average, right? And then let's compare. Okay, so I'm comparing these students on a bar graph, right? This is not an accurate representation. This does not tell me that student B over here actually was getting 80s in the first quarter. Okay, so how do I get a better idea of this? What? I add these things called error bars. Okay, so error bars are basically showing you, okay, here's the average. That's this big bar that we're used to seeing, right? And then here's this black line that's showing you like, but here's the variation. Here's how we got to that number. We had this far below the average and this far above the average, and that's what gave us this 66. So from looking at this data, I can tell like, okay, student C generally performs around a 66. That error bar is really low, it's really close to the mean, which means that the mean is an accurate representation of how this student's been doing. Here, when I'm looking at B and A, I'm thinking, this is not an accurate representation of how the student's been doing, right? So the mean is not as meaningful over here because the error bars are so large. It's telling me that something's going on in this data where the individual data points are not quite in line with the mean. The mean does not represent them accurately, right? So for example, if you have a 66 average and but you got 80s in the first quarter and somebody said like, oh, you're a D student based on the mean, woo, that's mean, right? You're not a D student, you hit a little bump in the road, right? And then we need more data points from there. You'll do great, don't worry. Okay, so you have this in your packet, right? So if you are doing your packet, which you totally are, because it's a great way to study, says the woman who writes your tests, you are gonna look in here and you're gonna see the same exact little cartoon guys, right? And it's gonna show you, right? And it's gonna show you a bunch of error bars and things like that, okay? So you wanna think to yourself, you know, what would make me second guess the data, right? Another really good example that I like to give are all of the, especially because we're doing a fitness class, right? Are like all of the weight loss claims that you'll see, like if you go on the keto diet and you eat exclusively fat, like and cheese with sour cream on top. I think that's what it's about. I don't know. But there are these promises that companies will tell you about if you follow their diets, if you follow their meal plan or their exercise plan, this is the average amount of weight lost. Okay, so let's say that you're looking for weight loss and it says the average weight loss is 10 pounds. Well, if the average weight loss is 10 pounds and I've got an error bar that's short, okay, I'm likely to be in that range if I do this program. If I do this program, me as a data point, I am likely to fall pretty close to the average, to that 10. This one, right, has a giant error bar. So it's a little bit lower. So let's say that this diet plan promises that you're going to lose, let's say 7 pounds, right? Or not is what this line is telling you, or not, or nothing, right? It's saying that that number 7 came from a huge span of data, right? And that the mean of 7 is actually not representative of many of the data points. Okay, so hopefully this clears up error bars for you. I wish I could see the error bars for so many things, but the next thing that we're going to do is standard deviation, and then you're going to see how the two of them come together. They are best friends, and hopefully this made sense. If not, I'm going to see you in class in like, I don't know, an hour. So then you can ask me, or you haven't seen this yet. Then you're going to see it later tonight. Then you're going to ask me the next day. Good times. I always try to solve like that.